Hello, today I'm going to do a graphing summary of all the possible graphs that you can think of. All right, so here we have two axes and we're going to make sure we label them. One of them is a position time, the other one is a velocity time. And we're going to just analyze an object traveling at constant velocity. I'm first going to do one case, which is the case at rest. Technically, that's also going at constant velocity, and the velocity will be equal to 0. So let's pretend that we have an object at rest. Hopefully you remember it is a horizontal line on a position time graph, like so. And I'll label that at rest. And so when you draw it on a velocity time graph, it will look like this. And it's also at rest. For any object going forward, or let's say headed east, it will look like this, for example. So this would be going forward at constant velocity. This has a positive slope. All right, so this here is a slope and it's positive. So therefore, when you draw it on a velocity time graph, it will be located over here. So this here is going to be constant velocity forward. Okay. Now, if we want to go backwards, it would look like this. And it could start anywhere, up there, up there. It doesn't matter where the start position is. Remember, it's the shape. The shape is going to be a negative slope, like so. And so this here is heading backwards or the opposite direction. And the slope in this case is negative. When you graph it, then you will notice it will be below in the negative quadrant, like so. Constant velocity, and it's going backwards. You'll notice that any graph that has constant velocity, all these lines are horizontal. All right, next we have an object that is speeding up. So an object that is speeding up, remember it's a parabola and it looks like this. And again, it doesn't matter where you start it as long as the shape is a parabola. So I'm going to start right from the origin just to make it easier. Okay, and I'm going to call this the right side, and it's of an up parabola. Now parabolas, you know, in math are kind of like you have, it looks like this, like a big U. So basically this is the right side of a U. This is an up parabola, and the other one that I'm going to draw in the future will be a down parabola. So this is a right side of an up parabola. All right. Keep in mind that this is on a position time graph, and we're now going to draw the velocity time graph. This here is speeding up, and we are going forward. So on a velocity time graph, we're going to assume we're starting at 0, okay, because here the slope is kind of at 0. And so we're going to start at 0 and we're going to speed up like so, and that is the velocity time graph for this parabola. So speeding up, forward. All right, going backwards. We're going backwards or we're headed the opposite way. So it's just a mirror reflection like so. And this is going to be speeding up backwards. Notice it is a down parabola, so it's an upside down U. So this is also on the right side. So this is the right side of a down parabola. Now, anytime you have a down parabola, you're going to have like negative slopes here. And so, yes, you're going to head in the opposite direction like so. And so this here is speeding up backwards. A good example of speeding up backwards is, let's say you're stopped and you want to get out of a parking spot, so you have to reverse out. So you're going to speed out initially, and then of course you have to brake because you don't want to hit anything. But this is what that means, is to speed up. Now notice I say it's constant acceleration. Speeding up also means it's constantly accelerating. Now it's constant because these lines are straight, they're not curved. The speeding up forward has a positive constant acceleration because you're going forward. The going backwards has a negative constant acceleration because you're going backwards, and it's found in the negative part of the velocity time graph. All right, the last example that I'm going to show you or explain in the summary is an object slowing down. All right, now for an object slowing down, it's just the opposite of speeding up. So yes, you're still going to get a parabola. The difference is it'll be on the other side of the parabola. So I'm just going to slow down, but I'm still going forward. An example of this is slowing down to a stop sign. So I'm going to have a high or a fast speed or a slope here, and I'm going to slow down to a stop over here. This part over here is stopped, and so that's the top of the parabola. In this case, this parabola is a down parabola, and this would be your vertex in math, in math class when you're learning about parabolas. So this section is stopped, and you start off with a certain speed. So I have a fast speed, I'm slowing down to a stop. So this is slowing down, but you're still going forward, right? Because when you're still slowing down, you still travel forward. On a velocity time graph, you're going to start off with a high speed, and you're going to slow down to a stop. And I'm just going to draw the stopping part over here so you realize where the stopping part is, okay? So this here has stopped because it's horizontal, and this here has stopped as well. You'll notice that it doesn't go below, all right, because that's going backwards, and we want to stop. And if you want to stop, you've got to make sure you're on that zero line to indicate that your speed is 0 or you have stopped. So there you go. All right. Now let's do the example of slowing down but going backwards. Okay, so we're going to slow down going backwards. It's just a mirror reflection of that, and it is a mirror reflection of this as well. So let's just draw that. And if you want, we can draw the stop section as well. This is nice and horizontal, and it's the same thing for both sides. So this here is slowing down, and I'm going the other way. So in other words, backwards. Okay, perfect. This here is the left side of an up parabola, whereas the slowing down forward is the left side of a down parabola. So basically, anytime you're slowing down, it'll always be the left side of the parabola. Anytime you're speeding up, it will be the right side of the parabola. You'll also notice that slowing down is constant acceleration as well. And so when you have constant acceleration like this, okay, these are straight lines. Just like over here is speeding up, these are also straight lines as well. So that's it for all the different types of graphs that you can think of, curves and straight. So speeding up, slowing down, at rest, constant velocity. Hopefully that little summary has helped, and continue graphing. If you have any questions, feel free to contact me. Bye now.